Woohoo! Welcome back. Today we're going to practice reading the graphs of functions. And for us to do this today, I've copied a couple of graphs from the book, and I have tried to be very clear when there are closed points as far as I can tell. Sometimes it's hard to tell. So this is why I've decided these are the closed points. Remember, that means if it's closed, that means the point exists. And if it is open, you can see I've drawn some of these and I really exaggerated that they are open. That means that the point is not included. So for whatever reason, so over here, the graph swoops down and then it stops, and this point is not a point on the graph. And in fact, it jumps down here, and this is the point that's included. And if you remember the vertical line test, you know that for any given x value, like along this line where x equals 1, you can only have one point and have it still be a function. So whoever came up with these graphs decided the point would be up here rather than right there. And so that's part of why you see open and closed points. Of course, this last point here is open, and we don't have any more information. We just have the graph that we're given. So we're going to just read the graphs. So before we get started, I'm going to mark up the graphs a little bit more. I notice I do have my x and y written in, and I've tried to emphasize the different parts so that it's easier to see in the video. This only has a very simple scale included. It has a 1 here. Number 1 is right there. And I'm just going to write in the rest of the scale because I think that's going to make what we have to do a little bit easier. You don't have to do this. There's -1 and there's -2. And notice that given that it goes from the origin up to 1 and from the origin over to 1, it means it's a 1-to-1, right? Each little box is 1 unit across and 1 unit up. Same thing here. We see this is our 1 there. There's our 1 there. The origin is right there in the middle. So we've got 2, 3. This is 2. This is -1, -2, and then this will be -1, -2. So, so that's, I've written in all the scale. Again, it can be helpful. You don't have to do it. Our first question is going to be, what's the domain and the range for each one? So I am going to separate this into 2 different sections, so that we've got this graph on this side and this graph on this side, just to be a little bit more clear what we're talking about. For the domain and range, remember that the domain is the x's in general, and we want to look at all the x values that are included in this graph. So I see that there doesn't seem to be any graph to the left of -2, but that as we move across between -2 and 3, I see the graph continues, and there are no gaps or breaks. So it looks like my graph goes from -2 to 3 inclusive. And in terms of the y's, that's going along the vertical axis. The lowest point does seem to be -2. And now notice that we don't just start here where y equals 1. We start at the lowest y value. So when we're looking at the range, we're not necessarily reading left to right. We're just looking what's the smallest, what's the largest. It goes from -2 to 3, just like with the x's. Kind of cool. And I double check there are no gaps. There are no missing y's, so it doesn't jump over any y's. And so for my y's, for the range, again, I also get -2, 3. Now let's look at the second graph. The second graph is a little bit harder to read because it's got all these jumps, right? It's got bits that are missing here and there. And so as I read left to right, again, the x's will give me the domain. I still start at -2, and now I'm going to read across. It comes down, and then I'm a little worried, but it jumps down, and it includes -1. Okay, then it swoops up, jumps down, goes all the way down, and then interestingly, it doesn't include this last point at 2. So my domain is that it goes from -2 all the way. There are some jumps, but every x is accounted for, all the way up to 2, but 2 is not included because that's an open circle. So it would be -2 is less than or equal to x is less than 2. Okay, let's look at the range. And again, this is not going to be easy. When I look for the smallest or the lowest number, the number that's the furthest down, I see that it does seem to start at -2, but that is not included. And then it goes up. Let me check all the y's. Y's are included. This one jumps up. This one. It looks like all the y's are included up to 2. So again, it looks very similar, but in this case, the open circle lies on -2. So there we go. Woohoo. So those are the domain and range. Next up, we want to know when f is increasing or decreasing. Okay, so what is increasing? Increasing means going up. So increasing, we're looking for things. I'm running out of room. I'm going to bring in a little card here. Increasing means as we read it left to right, it means it's headed up. And decreasing, again, left to right, it's headed down. And so what's interesting is we always read it left to right. So when we say increasing or decreasing, we mean the y values are getting bigger, or the y values are getting smaller. So increasing or decreasing, we really mean the output, not the input, because the input, we're always going to read a graph from left to right. Okay, so let's take a look. Increasing is that way, decreasing is that way. So let's take a look on this. Intervals on which f is increasing. I think f is increasing right there. So this interval right there. And now, what interval do I say? Do I say -2 to 3? And the answer is no. When it asks for the intervals on which f is increasing, it is asking for x for both of these. It wants to know the x values. So when is y getting bigger? Y is getting bigger from this point when x is 0 all the way up to this point when x is 1. So I'm going to include the 0 to 1. Now, you might ask, wait a minute, those are closed points. Why are they open? Why are they parentheses? It's a really good question. They're parentheses because this top point isn't increasing or decreasing. It's just sitting there at the top. And this point is just down at the bottom. Now, there are going to be times when someone might look at this with brackets, but in general, we're going to look at it as just the points in between the bottom point and the top point, if that makes sense. Now, decreasing, it looks to me like this one goes down and this one goes down. So I think I've got from -2 all the way to 0. And then you could put in a comma, or you can put in a U. And then this one is from 1 to 3. And it's kind of nice in this case because there's no point where it's flat, right? You can be neither increasing nor decreasing. You could be just perfectly flat. But for this, since it keeps moving around, I start from -2 to 0. So it's decreasing, then increasing, then decreasing, and it covers the whole function. Okay. So, increasing on this. So, you know what? I realized I wrote x intervals for x. There we go. So for increasing, again, I think it's just that middle spot. It's kind of interesting. This actually has a very similar shape. It's kind of interesting there. So the increasing goes from here when x is -1 all the way to here when x is 1. And again, I'm going to list these as open intervals because I'm not going to include the beginning or the ending points. For decreasing, it'll be the other two portions where they're going down. Looks like that piece from -2 to -1. And you could use a comma instead. Or from 1 to 2. Okay, so far so good. Woohoo. Find all local maxima and minima, or minima and maxima. So, the first thing to talk about, let's see, I can use the back of this or another card. This has to do with Latin. Minimum is what's called, and a lot of languages don't have this, some do, Latin does. In addition to masculine and feminine words, there are also neutral words. Minimum is neutral. The singular, minimum, turns to minima in the plural, and maximum becomes maxima. Just fun facts, things that you now know that you might not have known. So when we say find all local minima and maxima, we're saying plural, lots of them possibly. So let's take a look. Local minima versus global minima has to do with where you're the biggest or the smallest. So when we ask for local, that means that we're looking for any point that's higher than all the other points around it. And so we're going to include, like if we were thinking about an analogy, if you're the mayor of a city, that means you're very high ranking in the city. But usually the mayor of a city does not rank as high as, say, the governor of a state. And the governor of a state might not rank as highly as the president of the whole country. And so each of these, the mayor, the governor, the president, is a bigwig with all the folks around them, but maybe not overall. But that's what we're looking for here. We're looking for all local, so we want the mayors, we want the governors, and we want the presidents, all of them. So I see, let me cut this, give ourselves some spots. So minima, maxima. Now this one gets a little bit tricksy because sometimes it may be that they want the whole point and sometimes they just want the y value. Let me show you what I mean. For the minima, I see a very low point here, that point right there. So that would be at the point 0, -2, or it may be that they just want the y value. Does that make sense? So they may want the whole point because there's a minimum right there at that point, or they may just want the y value. The minimum there is y equals -2. Now notice that for this function, this is actually a global minimum as well. It is absolutely the lowest point on the whole graph. Now I see one other minimum. Where is that? Hopefully you see this one right here, the one at 3, 0. This is a local minimum because near it, it is the smallest one of the points near it, even though it's not as small as this one. Okay, what about maxima? I see 2 of them for this graph. I think this graph has an overall, this is the global max, is here at 1, 3. Oh, did you see? You probably saw my mistake. I didn't even see it. Oh my goodness. Do you see it? I'm gonna fix it. I'm so sorry. I wrote down the right thing. I don't even know if I said the right thing or not. What is the minima at 3, 0? It's the y value. It should have been 0. Sorry about that. So 1, 3 is a max, and this in fact is the global max, but there's one other local max. That's this point, -2, 1. And that point is larger than all the others. And now the thing is we don't know enough about the function to know if maybe there's more points, this goes down or this goes up. So we always check the end points because frequently they are a max or a min. So always double check that. Okay, over here, minima and maxima. So this is complicated with all these broken points, broken pieces. So I claim that this point is a local maximum. Do you agree? It's a local maximum, I think. So I'm going to do -2, 2, or 2. And then there's also a local maximum that's right here. And that is this point, which is 1, 2. Now, here's the question. Should this count right here, 1, 1, as a local max? And the answer is, I would not count it as such. Although it is the highest point that this piece gets to, if you look on the other side is up above it. And even though these are not connected, we probably would not consider that to be a max. Same thing here. I don't know that I would consider this a min since there's a shorter, there's a point that lies below it here. So this is a little tricksy. But for the minima, I would think I would pick this point. So this one is at -1, -1. Or just this. And now the question is there a local min here? And I would say no, because the point doesn't exist. So it can't be a minimum on the graph if the point isn't included in the function. So if this were filled in, it would absolutely not just be a local minimum, it would be a global minimum. So there's something interesting happening there. Okay. Over what intervals is the first graph greater than the second graph? So I did try to line these up so they are generally comparative. So you can kind of see like this is where 2 is and it mostly roughly aligns with where 2 is. So over what intervals is the first graph greater than the second graph? So if we take a look here, I see that at -2, I start here in the first graph. And I slide all the way down here. And I do think that let's see, first graph is greater. I think because the first graph is right here, I think there's a little portion, and I don't have my yellow, there we go. I think there's a little portion right here where the first graph is greater than the second graph. It's a little hard to read, but I think it is right here. So it's right there because the second graph jumps down and the first graph is just sliding down. So I think this interval would be from -1 to, and here we have to eyeball it, I'm going to say it's to about -1/2. And again, this is not going to be precise because we don't have exact values. Then this graph goes up, and it goes up to this point up here. So it goes like that. And I think at some point right here, this graph jumps over the second graph. All right, so this is the first graph. I think somewhere around here. So either around 0, maybe, or maybe like 1/5. You would have to, I mean, we could discuss it. It's really hard to see. So I would accept a lot of things. I'm going to say like 0.2 all the way up to 1. But then it then kind of comes down like this. And then, in fact, the whole thing lies above the rest of this graph. So I would take it all the way to 2. And then we've got a problem. Why do we have a problem? Well, the difficulty here is that even though the first graph is greater over this whole section, the second graph is not well defined between 2 and 3. So then it becomes a question of, well, do you mean, should we include this or should we not? My tendency would be to say, I don't think we should include it. The other thing is we could say, well, should we include the endpoints here? And we could. I mean, I could go back and I could say at -1. So let's see. At -1, it is higher. It starts right there. So I could go back and correct this and say, you know what? I could use a bracket there because at 1, it is greater than this number 2 graph. And that it continues to -1/2. I would use an open because I think that's where they intersect right there. There's an intersection point right there. So I would say don't include -1/2 because they're equal at that point. Same thing here. There's an intersection at 0.2 or whatever value you think that is. And that continues until 2. And the thing is I don't know what the second graph is when x is 2. It's not included. And so I don't think I could make that a bracket. But I think I could reasonably say, you know what, we can include a bracket there. So why did I include this problem given how many difficulties there are? The answer is you're going to have to kind of use your best judgment, take a guess, give it a try. When you're doing homework in WebAssign, I realize sometimes it can be very frustrating because they have a definitive answer and you're thinking it's not that obvious. So if you run up against any of these problems and you're like, wait a minute, how do I do this? Then, talk to me, talk to the tutors. We'd love to help you out. Do your best, make your best guesses at things. Understand that it's totally reasonable to make mistakes, and it's always totally reasonable to go back and reconsider your answers and say, you know what, I think I actually changed my mind. I think this is a better answer. Because sometimes the answers are a little wobbly and it's not always obvious and black and white. So hopefully most of this made sense. Hopefully you feel a bit more comfortable, but again, ask lots of questions. And this was an especially long video, so do take a break, get something nice, good to drink, something to snack on, and know that I think you're amazing and awesome. Math on and woohoo.